Varshini. So today's our topic is about web-based visualize for structural representation of C programs. So introduction. Compilers internally transform source code into different structural representations before execution. So these representation helps in understanding program structure, execution flow, and data dependencies. So this project is a web application that helps user understand how a C program is processed inside a compiler. So this project develops based on visualizing that analyzes C programs and displays tokenization, that is lexical analysis, abstract syntax tree, control flow graph, data flow graph, code property graph. So the system provides an interactive and visual learning platform for compiler concepts. So instead of showing only code, it displays all graphical representations like AST, CFG, DFG, and CPG. The next, the problem statement is about students frequently learn compiler concepts theoretically but struggle to visualize how the source code is processed internally. So it helps to so it is important structure. It gives structures such as tokens, syntax trees, execution paths, data dependencies are difficult to understand without graphical representation. So this project bridges the gap by providing a visual learning environment. So when we write a C program, the compiler does not execute it directly. So it first converts the program into the different internal structures. So this helps students to understand compiler concepts very easily. Next, the objectives. So the primary objectives are to analyze the C source code and to perform lexical analysis, and followed by generating the structural representations, then visualizing the execution flow and the display data dependencies. So, main objectives are analyzing the source code, performing a lexical analysis, and generating the AST, CFG, DFG, and CPG. And in educational objectives, we can see improves understanding of compiler design and connects automata theory with practical implementation. Demonstrates program analysis techniques. So, improves compiler knowledge to understand these. And we can see we are having the system architecture. First we are having input layer as the C, we are giving C program code as input layer. Then it is followed by generating the lexical analysis, which is tokenization. So performs tokenization and identifies token from the input source code. Then followed by parsers. So checks syntax and builds structural representation of the code. Then followed by AST generator, generates abstract syntax tree representing the program structure, then followed by CFG generator. So creates and control flow graph to the represent flow of the execution, followed by DFG. So builds data flow to show data dependencies between the variables. Finally, it will generate CPG by combining all AST, CFG, and DFG. So combines AST, CFG, and DFG to form code property graph. So output layer will look like a tokenization table, followed by AST, followed by CFG, followed by DFG, and then by CPG. So user interface web applications are code editors, analyze buttons, visual outputs, and interactive views. Then the tokenization. So what is tokenization means? It is the first phase of the compilation. So the compiler breaks source codes into smaller meaningful units called tokens. For example, int a equal to 5. So in token types, keywords, identifiers, operator, constants, punctuation symbols, and strings. So the compiler uses tokens to understand the program. Abstract syntax tree. So AST representation, an abstract syntax tree represents the hierarchical structure of the source code. It eliminates unnecessary symbols and focuses only on the problem logic. For example, C equals to A plus B. So the tree shows like assignment operation, addition operation, all the operations comes under that code. So advantages are simplifies program representation, it supports syntax validation, helps code optimization, used by compiler and interpreters. So in our project, AST is automatically generated after parsing the input program. So CPG, CPG represents the execution flow. So CPG represents execution flow of a program. It shows how control moves between different statements and conditions. Features are it displays execution sequence, represents decision making structures, shows program branches, helps to understand the program behavior. So the project generates CFG using graphical nodes and edges to visualize execution paths properly. So next DFG. So the data flow graph shows how data moves between variables and the operations. It tracks dependencies among variables during execution. For example, like features comes under this are variable definitions, variable usage, data dependencies, computational flows. For example, A equal to 5, suppose we have A equal to 5, B equals to 10. So the DFG looks like A plus B. So finally, it will be giving answer by adding the two numbers. So DFG focuses on data movement rather than the execution flow. So DFG helps visualize how information is processed inside the program. Code property graph, the final stage of our the final stage of our ATC visualizer assignment. So the code property graph combines multiple program representation into one un, unified structure. It integrates like it will be having addition of these three: AST, CFG, and DFG. AST for program structure, CFG for execution flow, and DFG data dependencies. But benefits are it will like complete program understanding, static code analysis, software security analysis, and vulnerability detection. CPG provides a comprehensive view of source code behavior. Then we are having a working and result of our assignment. We are having a lexical analysis, abstract tree syntax, CFG and DFG, and followed by code property graph. Our projects looks like this. Then advantages are it is very easy to understand compiler concepts, interactive learning environment, provides visual representation of code analysis, improves program understanding. It is very useful for students and beginners to understand the concept behind the compiler. Demonstrates real compiler workflows, and it connects theory with practical implementation, which will helps to easily understand the concept. Finally, at the conclusion, the web-based visualize successfully demonstrates the structural representation of C programs. So the system performs tokenization, AST generation, CFG visualization, DFG visualization, CPG visualization. So the project provides an effective platform for learning compiler design concepts and understanding how source code is analyzed internally. Uh, by learning it theoretically, students do not have the idea how the compiler works inside a machine. So it also highlights the practical application of automata theory in modern software system. So compiler it helps to students how to understand the compiler processes works internally. We'll next move towards the code. So we have created this project by using app.py, style.css, script.js, and index.html. Here we are having a lexical analyzer. We want to paste a C program code here. We are having a sample program here. It will loads if we tap on this. For now, we are going to paste on another code. This project is dynamic and it is not static. It will work for any basic code which is having if else block statements. Now it will generate the tokens. So here we can see it is showing the total number of tokens with the line numbers, which line is having which tokens, and Lexme and token, what type of token type, and the it is also showing the category. It is preprocessor, header, keyword, identifier, delimiter, what it is. We can see here. Then the second stage is creating the abstract syntax tree. So AST will appear here by tapping the analyze button. We can see AST here. It is showing the proper structure. We are having program function main, in which what is declaration in the code and what is declaration once again what is declaration. So in if statement, which what we are having, like basic salary is should be greater than 25,000, then in that then block and else block will comes under. We are having the function call, which function is called, and the final process is return 0. Here we can see in then block assignment total salary, we are having basic salary plus 5,000. Like this, it is showing the proper structure. Then the CFG will look like this. The starting node, it is followed by the decision node, and then true or false nodes we are having, and then followed by the printf stage, and finally return end to end. The control flow graph kind of looks like this. The data flow graph, it will generates the proper data flow graph containing all the codes having the main important things, like which is the constant here, which is having the connection, which is adding, which is getting subtracted, and which is getting the printed finally. And we are having code property graph, which is a combination of AST, CFG, and DFG. It will shows the main function, it will show the declaration, and it will show all the statements, like if statement, then from if statement, then and else block, in which what are the total salaries are having, return 0, call like printf and all. Next we can we can see here in CPG, finally code property graph combines all the ASTs, CPGs, and DFGs into a single graph. When the code gets longer, the when the code gets longer, the graph gets also wider and wider. So it will, for simpler and smaller code, it will look neat and clean. So this provides a comprehensive representation of the code, and it is useful for advanced code analysis and vulnerability. And for generating the DFG is how data moves through program. It represents dependencies between variables and the operations, as we can see here. And for CFG, it controls the flow graph representations, so that the execution flow look like this from starting to end. And the AST, like it represents hierarchical structure of the program. So it shows how statements and expressions are connected and organized inside a compiler. So we can run for other two other codes also. We can check it for other codes. As we can see, it is showing your total tokens are 54, which are delimiter, which are identifier and all. And if we tap analyze, so the AST will look like this with the proper structure. As we can see, the if a code is larger and bigger, the structures get wider and wider. We can see here the numbers are changed for from salaries to another codes values. So the values of DFG also changed from previous code to this code. So this is the dynamic one. It is not static at all. So in the code, we have not given any proper code for which it should generate DFG and all. And finally, the code property graph also changed for the given C source code. So finally, we can better understand how the internal structure of behavior of the C program usually using visual representation. So this makes compiler concept easier to learn and analyze, which will help to read for only simple basic C code. So for this code, it will work neatly and correctly, perfectly. Project, we can better understand how the internal source code will be going to uh, do its job internally inside a machine. So it makes to understand the compiler like the job of the compiler easily, and which will make concepts easier to learn and analyze. Thank you.